Good morning, everyone. I'm excited to be here for the Airflow Summit, and today we'll be covering orchestrating Databricks with Airflow. So we'll explore how you can leverage the latest Databricks features, including materialized views, streaming tables, and AI capabilities, all orchestrated with Airflow. So we'll walk through a live demo showcasing some of these functionalities. So here's what we'll cover today. We'll start by giving an intro to the Databricks Data Intelligence Platform. Then we'll dive into the practical stuff, how to orchestrate Databricks with Airflow, specifically covering some of our newest and most exciting features. Then we'll do a live demo showcasing how to build a multi-agent Airflow pipeline that orchestrates Databricks objects. So this is a technical session, so you can expect to see real code and practical patterns that you can use in your own day-to-day life. So let me start by setting some context. The Databricks Data Intelligence Platform is built on a platform of unified data stored in an open lakehouse format. So what makes it a data intelligence platform is we apply AI that has a deep knowledge of your specific data to enhance everything you do with analytics. So this isn't just about having AI features, it's about having an AI that understands your data's structure, its lineage, your business context, and governance requirements. The platform has several key components. The LakeFlow handles ingestion, ETL, and streaming. Databricks SQL provides data warehousing capabilities. Our AI BI product gives you business intelligence. And Mosaic powers artificial intelligence workflows. And everything runs on Unity Catalog, which is a unified governance layer. So today we'll be primarily focusing on DB SQL, Mosaic AI, and LakeFlow, and showing how Airflow can orchestrate these components. So let's start by talking about LakeFlow specifically. It's a unified solution for ingestion, transformation, and orchestration. It consists of three main components: LakeFlow Connect for ingestion, LakeFlow Pipelines for declarative ETL, using streaming tables and materialized views, and LakeFlow Jobs for orchestration. So here's how these components fit together. LakeFlow Connect brings in data from cloud storage, message queues, databases, as well as third-party enterprise applications. LakeFlow Pipelines transforms that data using either batch or streaming patterns. And all of this sits on top of an optimized storage layer with unified governance through Unity Catalog. Now, I know many of you use Airflow for orchestration, and that's perfect. All of these components work beautifully with Airflow, as we'll demonstrate today. So for ingestion, we have LakeFlow Connect. And so to explain this product, I want to talk about three things that I'm particularly excited about. The first is simplicity. The second is unification with the rest of Databricks. And the third is efficiency. These connectors are easy to set up. There's a simple wizard where you can create a production SaaS app pipeline in 4 steps and a production database ingestion pipeline in 5. There's an equally simple API if you prefer to code rather than to point and click. And once you have a connector set up, it's also fully managed. Insofar as we have the ability to solve a problem, Databricks holds the pager when something goes wrong. And here's where we are with connector availability. We have GA connectors for major sources like Salesforce, Workday, ServiceNow, and NetSuite. Many database connectors are in private preview or development. All of these connectors are a point and click, but they create a pipeline behind the scenes that can be orchestrated through Airflow. So now let's talk about LakeFlow declarative pipelines. This is where you build ETL pipelines in either SQL or Python. The keyword here is declarative. You can define what you want rather than how to get it. The system will automatically figure out dependencies, create a DAG, handle incremental processing, and provide built-in quality checks and lineage. There's 2 main components for our declarative pipelines platform. Streaming tables are the first one. They allow you to ingest and transform streaming data with either simple SQL or Python. It makes streaming data accessible to SQL analysts or Python data engineers, handles high volumes efficiently through incremental processing, and enables real-time use cases. So in this example, you can create a streaming table that reads from either S3 or Kafka with just a simple create streaming tables statement. No complex Spark structured code required. The second component for declarative pipelines is materialized views. This is another declarative construct that solves two major problems. The first is it allows you to pre-compute and store query results, which allows you to unlock query acceleration. Your dashboards and BI tools can query pre-computed results instead of hitting large tables repeatedly. So this allows you to unlock massive performance improvements for your end users. The second benefit is simplified ETL. Instead of writing imperative transformation logic, you can write declarative SQL, and the system will automatically handle the rest, including incremental refreshes. So this example here shows a typical pattern. You can join orders with customers, do aggregations by date, and then in a traditional system, you typically have to write your own hand logic to maintain this incrementally. But here, you can just declare what you want with create materialized view and add a schedule, and the system will figure out how to keep this up to date incrementally automatically. So let's walk through how we make materialized views fast and simple without requiring manual configuration. At the core of this is our cost model. What it does is it analyzes two things. The first is actual changes in your source delta tables, and the second is your query plan analysis. So based on this, the system will automatically pick what is the optimal refresh technique. So it could be either a simple append, a partition recompute, a merge, or a full recompute. The critical point is you don't need to choose. The system will choose what is cheapest and best for your use case. So it allows it to be fast and simple, incremental by default because you can get smaller updates since we're only updating the parts of the rows that are necessary, automatic, you don't need to do any triggers or scheduling scripts, and smart, it will automatically adapt to your data patterns. Databricks SQL is our data warehousing product. And we offer industry-leading TCO with AI-driven performance. And we do this with our predictive optimization. So what we do is we use AI to analyze your query patterns, data access patterns, table structure, and automatically optimizes everything else. And so we optimize with both storage layout, liquid clustering, predictive I/O. And the results speak for themselves. We offer 20 times faster at 50% lower cost for queries in many cases. And with DB-SQL, we also enable you to leverage AI right within your data warehouse. So you can call any LLM via SQL command using our AI query functions. So these work with OpenAI, Anthropic, Meta, as well as your own custom models that you fine-tuned. You can also use DB-SQL in your own agents that you build. So your own AI agents can query our data warehouse through our MCP server. And third, high throughput. So our CDWX benchmark shows 3 times better throughput than competitors. And so this is particularly useful if you're doing batch LLM inference over millions of rows. That performance advantage can be critical. And all of this is accessible through Airflow through the Databricks SQL operator. And so AI BI is our business intelligence product, including our newest feature, Genie. Genie is conversational analytics built right into Databricks. It literally lets you talk with your data. Instead of relying on dashboards, users can ask questions in natural language and get governed, secure answers from AI. Genie tailors these responses to your business context, so the insights are relevant and trustworthy. And then for external systems, Mosaic AI is our unified platform for building agent systems. It enables organizations to build and deploy quality agent systems. While other providers might have point solutions, Mosaic AI is built into the same platform as the Lakehouse and is a unified solution providing end-to-end governance for both data and AI assets, combined with a robust way to build, deploy, and evaluate agents. And so now let's get into the practical stuff, how you can actually orchestrate all of this with Airflow.
Oh, thank you. Hi, everyone. So everything we've shown you so far can be managed using the Databricks API. So what that means is you can orchestrate all of these products from Airflow. And what we typically see is 2 patterns of how people orchestrate Databricks from Airflow. So the first pattern we see is people creating a job directly in Databricks. So using the LakeFlow job product, you can create a DAG, which will have various tasks. So you can have a LakeFlow Connect task for your ingestion, a LakeFlow pipeline task for your declarative pipelines, Databricks SQL task. And then for any task that we don't have, we have a notebook task that you can use to call various APIs. And then from Airflow, you'll have one task, which will use something like the Databricks run now operator, which will orchestrate the LakeFlow job. The second pattern that we see is creating individual tasks in Airflow. So you'll have your Airflow DAG, and from there you'll have an operator for each of the different workloads in Databricks. So this is the exact same orchestration pattern I showed before, but here you have the Airflow DAG orchestrating the individual products in Databricks. So we support both of these use cases. There's scenarios where we don't have, so Airflow doesn't have an operator for a product. So for example, our new Agentbricks product, which I'll show shortly, doesn't have a operator. So luckily, Airflow actually makes it very easy to build custom operators. So all I did here was I copied the markdown from the astronomer docs for creating an operator. I copied the docs for our new API, put them in Claude Code, and it was able to create me a custom operator that I could use. Another pattern that I want to talk about is going from imperative programs to declarative systems. So typically you would write all the logic of what needs to be done, but with declarative systems, you just write what you want. So on the left-hand side, this is a typical Spark imperative program. We're defining all the logic of how to update a table. But with LakeFlow declarative pipelines, you can just define the streaming table, define a flow with auto CDC rules, or create a materialized view. And then this will all be managed by LakeFlow. So it will manage the compute, it will manage the transformations and all the incremental logic for you. We're also bringing this declarative system concept to a lot of our other products, especially products that have a user interface. So for example, with Agentbricks, we can automate the ingestion and embeddings for you for a pipeline for a vector search database. So typically, if you're building an agent, you need to write the code that will read data, compute embeddings, write back to another Delta table, or write to a vector search database. You have to handle all the kind of incremental logic. But with Agentbricks, you can just go into our UI, define the agent that you want, tell it the source of the data, and this will create a pipeline in the background for you, which will do all the embeddings and will write to a serverless vector search database. We also have similar things for like LakeFlow Connect, where you have a UI where you just define your source and your sink, and we will handle all the incremental logic and transformation for you. And with one of our newer products like Lakebase, which is our managed Postgres service, we have a reverse ETL feature where you can define a Delta table and a Postgres table, and we will spin up a pipeline in the background and manage that pipeline for you. And so with that, I'm going to show a demo of exactly how you can orchestrate some of these declarative systems from Airflow. It's cool. So here you can see our Agentbricks UI. So what I've got here is I've got one agent that is orchestrating multiple sub-agents. So on the left-hand side here, you can see my two sub-agents. The first one is an agent that helps you analyze data or ask questions about data in a vector search database. And the second one is a Genie-based agent that will answer questions for structured data in a table using Databricks SQL. So this will generate SQL and then give you an answer. And so with this agent here, which is our multi-agent supervisor agent, you can ask a question. So for example, I might be an analyst where I ask a question like, what cities have our competitors launched in based on the latest news articles? That information is all in the first agent. And then I want to understand the usage for the same cities, which will be answered by the second agent. So what you'll see here is this main agent will understand where to get the first information. So it'll get the list of cities from this first agent, get the result, And then from there, it will then pass on to the second sub-agent. It will pass in the list of cities, and then that Genie space agent will run a SQL query, get a result, bring that all back to the main agent, which will then kind of give a summary and can then even write some insights based on the response from those two agents. So you see here, we can add up to 20 different agents. And I'll show you now how easy it is to set up the sub-agents. So here I've got a materialized view that I've defined. I actually haven't set up a schedule for this one, because I'm going to have this materialized view orchestrated by Airflow. But to actually create a Genie space agent on top of this, all you have to do is click on Create Genie space. You can select one or multiple tables. And then you can see here, I have one table defined. It will generate some example questions to ask about that table. While it's doing that, on the right-hand side, you can see we've got a few options. So you can add more data. You can add some custom instructions of what the agent should do. And you have things like monitoring and benchmarks here for doing evals. So that's how simple it is to create a Genie space agent on your structured data. And next, I'll show you how we made the agent on top of the unstructured data. So here we've got a few options. The one I'm going to use is Knowledge Assistant. So you can click on Build, and it will take you to this form that I've filled in already. So all you need to do here is define a name for the agent, a description, so the agent knows what it's going to be used for. Provide a source. So here I'm pointing to a volume in Unity Catalog, which has all my news articles. I describe the content. I can add multiple sources here if I like, and then just click Create Agent, and that will create your Knowledge Assistant agent. So behind the scenes here, it's going to spin up a serverless vector search database, and it's also going to create the pipeline that reads from this source, computes the embeddings, and writes that to the vector search database for you. And so to orchestrate all of this, we can do all of this from Airflow. So what you see here is a DAG where I've got on the left-hand side my ingestion pipelines. So here I could be ingesting data from SharePoint and SQL Server. And what happens in Databricks when you create LakeFlow Connect is it creates a pipeline. And so you'll have a pipeline ID. So all you have to do in Airflow is use this task, the Databricks sub run operator, and pass in the pipeline ID. So it's a very simple operator to use. And the same thing for the materialized view. And that also creates a pipeline in the background. So again, I just pass in my pipeline ID. And then for the Knowledge Assistant, that's where I use my custom operator. So here we'll call the new API with the ID for our Knowledge Assistant, and then that will sync all of the sources. So if I click on one of these, you can see it will give me a link to the Databricks UI. So I can actually then go and look at what happened with the refresh. And so you can see, for example, with a materialized view, this will be the same thing for LakeFlow Connect. You'll see exactly how many rows were inserted into that table and get more information about the refresh. So that concludes the demo. I'll just go back to the slides. Cool. So just to end, just want to summarize a few key concepts. So ETL is still needed in Databricks to prepare data for your BI and agents. We want to show you how you can simplify your pipelines by using declarative systems instead of imperative programs. And we wanted to show you that you can orchestrate all of Databricks from Airflow. So yeah, thank you for joining.